Cool. Let's talk about chaos or something. Is this working? Does the remote work? Hey, the remote works. Yeah. So before we talk about chaos, let's talk about learning things. I love this quote by Barack Obama. Whether you like him or dislike him as a president, hopefully you like him. Doesn't really matter. But he said this fantastic thing about failure and not letting failures define you, right? He always had this nice positive outlook on things of, if there's a failure, you're not a failure yourself. It doesn't define you, but it should be a guide. It should be something that helps teach you about what you're working on and hopefully about yourself. So I love that because when it comes to chaos, this is exactly why we do chaos engineering, why we do chaos tests and experiments. Now, Barack Obama said a lot of things. He also talked about hope a lot. But for hope, I like this quote better. This is Corey Bertram. He's the former VP of SRE and infrastructure at Datadog. And he always told us that hope is not a strategy. You can't just hope that your systems will stay up. You can't hope that your deployments go smoothly. You can't hope that your customers never see problems. And Corey said this because Corey originally came to us before he was at Datadog. He was at Netflix. He was one of the original SREs that was responsible for bringing chaos into Netflix. How many people have heard of the Netflix and Chaos Monkey and all that stuff? Yeah. So it's super popular. And a lot of people think that Chaos Monkey was this tool that would randomly turn things off or randomly destroy things. And that's not quite the case. So Netflix actually had a process. And back in 2011, they published a blog post. That's the link. It's probably super small. But talk to me later if you want to see it, or just look it up on Google. It's now on Medium rather than on their original blog. But one of the things that they discovered, point 3 of the 5, was that a great way to learn is to constantly fail, right? And so that's what caused them to make Chaos Monkey and the whole suite of chaos tools. So I didn't come from Netflix. Quick little bit about me. I'm Jason. I'm a senior technical evangelist at Datadog, which essentially means that I have the fantastic job of coming and chatting to people like you and helping people understand technology and better ways that they can implement technology and work with it. My lab's on now. Oh, sweet. All right. So we will do that rather than playing with the handheld. Yeah, that's me. I also play a lot of Pokemon Go, so if you see me wandering around later, that's probably what I'm doing. Also, if you do play, come talk to me later, because today, 6 to 7 is raid hour. Everybody else is just like, I don't know what that means. It's totally okay. Datadog, a little bit about Datadog. Datadog is a SaaS observability platform. We do monitoring, your traditional metrics, infrastructure application metrics. We do distributed tracing, what's sometimes called APM. We also do log analytics. We also do synthetics, real user monitoring, a bunch of other stuff, essentially get you visibility end to end and help you find the issues. It's very important to have this when you're running chaos. But back to that Netflix story, right? So Netflix ended up building this Chaos Monkey tool, and a lot of people have heard the myth that it would randomly take things down or randomly destroy your infrastructure to test it, and that's not quite the case. So from their blog post, they say by running Chaos Monkey, not randomly, but in the middle of a business day, in a carefully monitored environment, and with engineering standing by to deal with any potential problems, that they could use that to learn the lessons about their systems, identify weaknesses, and then hopefully build automatic recovery systems, so that eventually you build up enough of these when an outage happens in the middle of the night on a weekend, you don't notice it, right? So there's a lot of these rules around how you implement chaos. And if there's anything that you get from this talk, if you decide that you're going to fall asleep right now because I'm boring, or you decide that those cookies in the back are amazing and you just want to go back there and eat those, learn this. This is the one lesson that you should take away. If you are destroying things randomly without telling anybody, without any sort of process, you're a jerk. Do not be a jerk, right? So lesson learned, that's all you need to know. But if you want to learn a little bit more, let's talk about game days. And this is how we implement chaos at Datadog. Game days are a little bit more structured, and they allow us to perform these experiments with a process. So the first thing that we do is we time box it, right? If you have an experiment and it goes on forever, then that's ill-defined and makes learning hard. So we time box things by saying that we're going to set aside 90 minutes. So every game day or every chaos experiment set that we run runs about 90 minutes. And we break that down into 30 minutes of planning. So we don't want the planning to be too big or too onerous because otherwise nobody's going to do it. And then we do 50 minutes of actual playing. This is the time where we get to destroy things. We get to see how they react when we take them down or we deprecate an environment or degrade an environment. And then we do 10 minutes of reporting. And similarly, you don't want to spend a whole lot of time reporting. If it takes you more time reporting than to actually do the fun part, nobody's going to do that, right? So 10 minutes is all we do for reporting. We try to keep things super easy. Let's talk about the team. Who's involved? So a lot of times people are like, they want to do it on their own. That's not so good because you're just on your own. Or they want to have everyone involved, and that can be a little bit of a challenge too, trying to get everybody on the same page. So we actually do it with just two people. One that's going to be the subject matter expert. This is traditionally the lead developer or the lead engineer that built that service or built that application. And then a member of our SRE team. So they partner up. The idea here is that the subject matter expert will know the ins and outs of that service. So when something goes wrong, when they try an experiment, this is the person that ideally knows why that's happening the way it is. And then your SRE is going to be your expert on how to keep things resilient, and they'll be able to provide feedback on changes that can be made. Occasionally, we do it with three people, and that third person is going to be a junior developer, junior engineer within the team. And the reason for this is that it's really easy for a senior engineer or that subject matter expert to know the constraints that were around when that service or that application was made, right? And so oftentimes you do really kind of bad things when you have constraints because you need to ship that new feature or you need to get that thing out the door. When you have a junior engineer, they don't know that. And so they need to pick up that information, and having them partner along during a chaos experiment is a good place to have that exchange. Because that junior engineer is going to ask, well, why did you do things that way? That's a total hack. And the senior engineer will be like, yeah, exactly. Here are the constraints. This is why. We've got a card for that. It's technical debt. We can resolve that. But at least now the junior engineer is able to ask these questions. The senior engineer is able to provide those answers. So I said that we spend 30 minutes upfront planning. What does that actually look like? Well, the first step in planning is to schedule it, right? So if you ideally have 2, maybe 3 people, scheduling becomes a lot easier. So you can figure out when in the day you want to do it. But again, remember, you're doing this during business hours when you're available. Don't plan for it at the end of the day because you don't want to stay late if something goes wrong. Don't plan for it on the weekend because hopefully you're having fun with your family or your friends on the weekend. The second is to pick the tests. Obviously straightforward. But when you pick tests, I recommend that people start easy. Don't go crazy. Don't come up with really complex scenarios because with the test, you want to build up to that. So you start something easy, and you also want to plan it in a way that you're writing down everything that you're doing, all those steps, so that you can easily replicate it. Because should something go wrong or should you discover something about your systems, which hopefully you are, you want to be able to replicate this so that any of those action items that you'll do later to resolve things, you can actually run the same steps and ensure that you resolve them. The third is to write down a hypothesis. What do you expect to happen? So if I take down the data store for an application, what do I expect from my application? Now, again, with that Netflix blog post, the idea was that you would learn about your systems and eventually you'd build those tools to auto-remediate. So your hypothesis shouldn't necessarily be that your systems should all stay up and running. If I take down a data store, it's quite possible that my whole application stops, but my hypothesis should be, well, my application stops, but maybe I have monitoring in place. I should get some sort of alert about this, and that's totally okay. The fourth is that we write down a plan B, because if we take it down,
Complex systems are complex. They could lead to cascading failures, failures in ways that we don't intend. Now, ideally, you're starting off in sort of a segmented environment, some sort of dev environment or staging environment. But even that, you want a plan B, because if you take down all of staging, you're now a blocker for the rest of your development team or the rest of your engineering team. So you want to have some sort of plan B where you can recover. And finally, most importantly, you need to share this document. So you write all of this down, you share it as broadly as you can across your entire engineering org, or if you're a small organization, maybe across the entire company, right? Because the idea here is to share what we're learning, let people know what you're doing, and that way they can respond. And if you share it beyond your engineering organization, it helps some of maybe your salespeople know, or your account reps know, or those people higher up in business who may not need to know necessarily the details of all the systems, but they want to know how your systems are doing and what you're doing in order to make them more resilient. So that's the 30 minutes of planning beforehand. The 50 minutes of playing. Well, when you're playing, we like to start off in staging, some sort of, again, segregated, segmented environment where we're not impacting customers. But after we run the test and we pass that, we'll move that into production. So again, we want to write down all of the steps for our chaos test so that we can repeat them. And when we repeat them in production, we'll do that first during our low peak hours or off peak hours. And then once that passes, we'll do it in prime time. We also make use of Slack a lot within Datadog. Whatever chat tool you're using, you'll want to make use of that. So we announce it in there. Partly because if you're just in the office and you turn or you stand up and you say, hey, everyone, we're doing the test. If someone's taking a potty break, if someone's out and they come in later, they don't necessarily know. So Slack or whatever chat tool you're using is a fantastic place to record that, because then anyone can see it and it can be asynchronous as far as notifications. We also want to maintain our chat within that chat tool. So I know it can be easy when you're in an office and you're working side by side with your partner on the chaos test, you can just discuss things. The problem then, though, is that makes reporting much more difficult. So if you keep everything within Slack or within your chat tool, it has a nice transcript right there. So all we need to do later when we're reporting to keep that reporting to a minimum is we just paste a link to that, right? We don't need to keep track of who said what did we see at certain times, when it's all within Slack. We also want to monitor for outages, because if we're running a test and suddenly production goes down, is that because of our test? Is that because of something else? We want to be aware of what the rest of the organization is doing during our tests to know if we're impacting them. And should something actually happen during the time when we're running the test, then we can just abort that, right? And we can let the engineers who are trying to solve that actual outage or that actual incident, we can let them focus on that, knowing that we're not interfering with them. And then finally, once we ensure that we're doing all of this for the actual test, we just run it and we take notes. So taking notes is the most important part of this because, again, you want to learn, and so capturing this information is important. Finally, for the after section. So again, we want to keep this down to just 10 minutes because nobody wants to spend all day reporting on this stuff. So we want to ensure that we create cards. As we're working through our test, as we're playing with our system, we'll make some notes, and eventually we want to ensure that these turn into cards. So whatever ticketing system you're using, Trello, Jira, whatever, the only way to ensure that all of this gets done is to make a card out of it. So we ensure that that happens. We write up a summary, and the summary, again, you can just copy and paste a lot of this from your notes. We want to write up a summary with some key takeaways. And then we'll email that out to our entire organization, or as wide as we can. Because again, remember, this is all about learning the lessons from our systems. So sharing this broadly, whether or not it's somebody within my own team, everyone can generally learn from these lessons. They can learn not only about maybe their systems, because they might have similar systems that are set up, but hopefully they'll learn a little bit about our systems as well, because as we build out a service-oriented or a microservice-oriented organization, it becomes harder and harder to learn about these other systems and how they impact our own. So this is a good way to do that. Most importantly for the after steps, you report and then you celebrate. We like to celebrate at Datadog a lot. We celebrate anything, any opportunity that we get, but you should celebrate. Because not only did you learn about your systems, hopefully you learned some insight about yourself as an engineer, you learned about your practices, and you're making yourself better. So whether your experiment went perfect and everything went according to plan, your hypothesis was correct, congrats, celebrate that, because you've built a great system that reacts exactly how you expect. But let's say everything goes completely wrong, and you run your test, and it was in production, and you took down all of production, right? Number one, fix that. Don't just celebrate. But celebrate after you fix that, right? Because you found something that was a critical flaw within your systems, and you were able to resolve that. And now, hopefully, on the next time, should that ever occur again, it won't be while you're not looking, right? You'll have the systems in place to alert you. You'll have systems in place maybe to remediate that. Or perhaps it'll never even happen again. So for those game levels, I did mention starting off small. Again, a lot of people are like, chaos, let's create as much chaos as we can. Let's take down this and that and this, and we'll also turn off half the network. That gets a little crazy. So start simple. We have a few levels at Datadog of how we start. Level 0, because we do zero indexing, is where we turn off that service. If we turn off that service, hopefully it should restart automatically, right? Hopefully we should get some basic alerting about it. So start off really simply. Can I turn this off? Does it turn on? Does it turn on without any human intervention? If someone has to go in there and plug in credentials or authenticate against some service to get those credentials in there, that's not automatic, that's not ideal. It means that if an outage happens in the middle of the night, somebody has to be there for it. So this is level 1. Everything should be able to restart itself. We also try to block access to one dependency, just to see what happens. And again, your service doesn't have to necessarily survive, but it should react in the way that you expect it to. It should have proper alerting or monitoring on it. Level 1 is where we block access to all the dependencies, so we get a little bit harder. Again, doesn't have to survive. A lot of the stuff that we build doesn't, but we should get proper alerting. There should be some sort of monitoring. That alert should have some sort of next steps or playbook behind it so that whoever gets that alert has a few action items that they can immediately take. Level 2 is we terminate the host. So we used to run everything on VMs. We moved to Kubernetes, but even taking down one of our Kubernetes nodes. What happens? If I'm in Kubernetes, does Kubernetes actually shift that pod to another node in the cluster? If I'm on VMs, does that VM, do we get alerts that it's down, and does that VM actually respawn, or does that service start on a waiting VM? Level 3 is where we degrade the environment. So we want to degrade the environment, things like introducing drop packets, network jitter, starting to max out CPUs on the hosts or the nodes, starting to maybe fill up the disk or increase disk I/O or latency, things like that. We want to see how everything responds. We also want to ensure at this level that our monitoring and alerting is complete. So we like to use the 4 golden signals, which are part of the Google SRE book. The 4 golden signals are latency, errors, traffic, and saturation. So we want to ensure that we have all the monitoring on those aspects, that we have complete tracing, that we have logs enabled on this. One of the great things about this level is at this level is where the on-call duties can actually be offloaded to the SRE team. So one of the nice things about Datadog is if you write a service, if you're one of the developers, you are responsible for running your service. That means you're on call for it. If you've ever been on an SRE team, who here is an SRE? Few hands? All right. Or shy people. A lot of times I talk to SREs and they're like, yeah, it sucks because I get woken up in the middle of the night for a service I know nothing about and I don't know how to fix it. So they essentially just become the middleman that then has to wake up a developer. At Datadog, our developers operate their own services. So they're on call. The great thing, though, is once you start running chaos, at this point, we're ensured that we have all of the proper monitoring on it. We're ensured that it reacts the way we want. So if there's an outage, if the host goes down, we know that it comes back up. All those basic things that would wake somebody up and they would click a button and go back to sleep and be angry, those are all automated, right? So at this point, this is where at Datadog, we allow our developers to pass off to the SRE team. So the SRE team can now be on call for it because we know that should something happen, they're gonna get a proper alert. That alert is gonna have some sort of playbook that says, here are the next steps, so they have a better idea of actually how to handle this outage. Beyond that, we have a few more levels. Level 4 is where we spike traffic. So we essentially do a bunch of load testing, see what happens to our application when we increase that. And then level 5 is essentially nuclear holocaust. Everything goes down. We try to terminate an entire region. We are also multi-cloud, so we're working on being able to terminate one of our cloud instances and see if things get replicated to the other cloud. We're not quite there yet with all of our services. Only a few have gotten to this level, but that's the idea. So I've just talked your ear off for a good amount of time. Hopefully, you want to actually get hands-on. And so let's actually try to do this. Live demo time. Cool. So I've got this amazing website. It's a WordPress site. Maybe I'll make it bigger. Yay. Cool. So yeah, it's a standard WordPress site. I've actually got it running in Kubernetes. You don't need to know anything about Kubernetes for this. But let's do that to just monitor the pods. So I've got Kubernetes running. I've got Datadog there. I've got WordPress, which, is everyone here familiar with WordPress? Yes? All right, if you're not, I've actually been to a conference that was like all enterprise people, and they're like, what's WordPress? WordPress is a PHP CMS. It's used for blogging. So it essentially runs Apache and PHP on the front side. And then there's MySQL on the back end. So that's what the second pod is here. Also, if you don't know Kubernetes, pods are, for better or worse, in this context, I'm just going to say they're magic VMs. You can just pretend that they're servers. It's totally wrong. All right. So if we were to start our chaos testing here, let's go over to, I think I have a gist here. Yeah, I do. Sweet. So we'll go ahead and edit that. Whoa. Why is that? Let's scroll down and it's completely blank. Edit. There we go. Cool. So the planning. Number one, we're going to schedule it. When is this happening? We are scheduling it for now. Yay, because I don't have that much time. All right, choosing the tests. So let's choose a test. It's a very, very basic system. Here, things are going to be more straightforward. Obviously, in your own systems, you probably have a bunch of services, and that's the fun part of chaos engineering is you don't necessarily know what's going to happen when you pull on a string and things start to unravel. But here, let's do something like, we're going to kill MySQL. MySQL. So I think first, let's try to, we'll delete the pod. Right, and see what happens. And then if we get to it, second, we'll delete the deployment. What do we expect to happen? Shout it out. Gets recreated, right. Okay, so I'm assuming you mean like the pod, right? So what we expect to happen if we delete, oh, actually, this is super tiny. There we go. Sorry about that. If we delete the pod, Kubernetes should recreate a pod, right? And then if we do the second one, if we delete the deployment, what do we expect to happen? Site will go away. Can we? All right, just MySQL goes away. What should we expect to see in WordPress? Yeah, okay, that sounds good. We'll see a 500 error of some sort. Cool, and then maybe we should get some sort of monitoring, right? Like if we should get some sort of alerting that MySQL is down. Cool. Those seem pretty sane. Good hypothesis. What are we going to do if things go horribly wrong? I'm probably just going to go back there and eat a cookie. So let's say, walk off stage, eat cookies. Awesome. So step 5, we'd share this. So congrats, you're all part of my organization. This is now shared. There's a gist. I'll share the link for this later. Cool. So that all makes sense. Let's jump into. So we've got our WordPress site here. It's working just fine. I'm going to jump into my terminal. And let's do something like grab that URL. Generate some traffic on it. Curl that. Done. All right. So now I'm just running curl on this, so we've gotten some traffic. Cool. So we can see down here in my lower terminal that everything's running. So let's see. If I do something like kubectl delete, if I spell right, delete pod. No, I do need an L. Let's go ahead and delete MySQL and see what happens. Copy that. Also, I'm running in Minikube, and I just upgraded, so things were like kind of wonky when I tried this before. So we can see that it's terminating. If we go over to our site here, hey, error establishing database connection. Interesting. So one of the fun things is, okay, it looks like it automatically restarted a new pod. But that is interesting, right? Normally you would think, hey, MySQL went down. It should be looking at that new one. So that's an interesting note. So this is the fun thing about chaos engineering, is you can find all sorts of things. So we take a note. What did we see? Well, we deleted the MySQL pod. As it was terminating, Kubernetes started a new pod. The WordPress front end, though, WordPress front end still got a 500 error connecting to the database. So that's interesting. So it looks like the old pod has completed. It's been terminated. The new one's up and running. And then if we go back to this, let's see if we refresh. Okay, so it finally came back, but that was actually a bit longer than I would think I would normally expect for Kubernetes. A few other things that we can do, though. We should be able to see if I refresh this page in Datadog, did it trigger an error? So it did trigger an error, right? I can see that my alert was sent. Cool. So pretty straightforward. Let's jump back into, what do I need? This. Cool. Fairly easy. We could also take notes of things that we didn't expect, right? So we didn't expect that it would actually continue to produce 500 errors as long as it did. Cool. Things that we should fix or change. Maybe we should have some sort of better error message because we got that horrible white screen. So we could make notes for that. Cool. Pretty straightforward. Do we want to do the second? I think it'll pretty much end the same, but if we do kubectl, delete, deploy, what did I call this deployment? We called this WordPress MySQL. So if we delete that deployment, okay, we see that the pod is starting to terminate again. If we go back to our site, we'll probably get that same 500 error. So an interesting thing is the first time we hit it, it was pretty quick. This one looks like it's sitting and spinning. So we're actually getting some sort of, I bet we'll hit some sort of timeout before the error occurs, right? So yeah, sitting and spinning. Cool, so we can take notes for that. We deleted the deploy. It terminated the pod. The website spun for a while, possibly waiting for timeout. Then it returns the 500 error. Cool. So again, not super complex. We took notes, we had a hypothesis, we're actually testing those out. What if we actually start this up though? Because again, one of our levels was we want to ensure that things start without any manual intervention. So if I reapply that kubectl apply, I'm just gonna, the MySQL YAML. Cool. So that reapplied it. We see that it's up and running. Wow, that was fast. If we go back to our website, hopefully we will reload. Cool, and we can also see that it kept all of our settings here. So the WordPress is still, MySQL is still running off that same data store. So looks like everything worked just fine. Cool. So the nice thing about having all these notes though and doing this as we're going along is it makes it super easy to come in for our quick reporting, right? Make Jira tickets from things we should fix or change. We should have a better error message, some sort of outage page. We can just copy and paste that. For the write a summary, we can, again, just copy and paste from the things we saw, right? And then just the easiest, saving this, sending it out in an email to the rest of engineering, and celebrating. So good job, good experiment, we're celebrating. Cool, so I'm gonna save that. And we can jump back into that. So hopefully that helped show you that experiments and doing chaos, not that hard, right? It's just simply following a process, coming up with a good hypothesis. But just to reiterate, right? Start with your game days or your chaos experiments. Start easy. Just turn things off. See if they come back without any manual intervention. Then move up to blocking dependencies, move up to terminating hosts within a cluster or larger things. And then work on degrading the environment. Degrading the environment really is, to me, the fun part. It's the more interesting one out of all of these. But again, once you get through those first three, those are really the basics of what you should have on any service. And then spiking traffic and terminating the cloud, those are sort of the bonus, the extra credit, the harder ones that you should be shooting for. Also, why is that? Let's go that way. All right, so just to recap, share. That's probably the most important thing out of all of this is chaos is about learning, so you really want to share this so that everyone can learn. And that really takes planning in order to do this right, so spend that 30 minutes of planning. Take that time before you go play, but when you're playing, have fun with things. See what you can break, see what you can learn about your systems. Obviously, they're going to be much more interesting than a simple WordPress site. A few additional resources though. What you saw me do was just simple stuff that was command line with Kubernetes. A lot of the tools that people are like, should I implement all this crazy stuff? A lot of the stuff that you're going to be using is simple things that are right out of the box. So if you're running on a Linux system, systemctl, kill, IP tables, those are all fantastic ways to destroy processes, to interrupt network traffic, to essentially run any of these experiments. Beyond that, we do use a few other tools. Comcast is one. Comcast essentially degrades your network. It introduces jitter, it drops packets. I don't know why it's called Comcast. It's just a random name. Vegeta is another one. Vegeta is a load testing tool that's particularly good. So it's one that we use a lot. The nice thing is it'll generate a ton of traffic, but you can also feed back those reports into the Vegeta tool, and it'll generate graphs and reports for you. Looks like I modified the slides out of order there. SurgeNG, which is, for some reason, the second bullet point here. SurgeNG is a fantastic command line tool. It also will help you degrade the environment. Surge will help you do things like maxing out a CPU or maxing out memory, I/O, and things like that. So it's very, very flexible tool. It's available on, I think, almost all Linux systems, or you can install it from apt. A few of the commercial stuff that's out there, Gremlin. I've been working with the folks at Gremlin for a while. They make a fantastic tool. Gremlin was founded by one of the other engineers from Netflix that helped build those chaos tools. So they have a free tier as well, which allows you to do shutdown attacks and a couple other things. So give that a try. And then Chaos Toolkit, similarly, is a nice framework. So at Datadog, we've been adopting more of the Chaos Toolkit approach, which allows us to write the experiments within YAML and then run them against our Kubernetes cluster. I think I'm about out of time. So questions, that's my email address. And I'm on Twitter as GetBisect, which if you meet JJ down here, he just calls me GetBisect, which isn't my name. But yeah, if you have questions about any of this, I'd love to talk with you afterward, or just hit me up in one of those formats, and I can answer any questions that you've got. But thanks.